Hello students, good morning everyone. Right, I hope you are getting the screen clearly. Well, students, we are discussing the concept of collisions from the chapter Work, Energy and Power. From the chapter Work, Energy, Energy and Power. Okay, and now we will see briefly a few points which we have discussed in the previous session. That session, some of you were absent, so I think even today also, very less number of the students are attending now. Okay, so anyhow, so let me brief out the points which we have discussed in the previous session. In addition to those points, let us discuss few more points. Okay, right. So what we have discussed in the previous class is we have discussed about what is a collision. We have discussed about what is what is a collision, and we have also discussed about types of collisions types of collisions types of collisions and here at this point we will see few more points, uh, and specifically yeah, let me revise once what is collision, then types of collisions also, then we'll continue few additional points under these types of collisions, and we'll go ahead and we'll continue. Right, what is a collision? So under this we have discussed that collision is nothing but an interaction. Collision is nothing but interaction in which momentum and energy, uh, what can you say is exchange takes place. Momentum and energy exchange takes place. This is simply, I think, just we have copied like a definition. If anyone has missed that session, now we can copy what is a collision means. Collision means interaction between bodies or among bodies, between two bodies or among more number of bodies, in which exchange of momentum takes place. Such kind of interaction will be called as a collision. So if you can write, if anyone has missed the previous session, you can write down what is a collision. Interaction and an interaction in which an interaction in which exchange of momentum takes place. Exchange of momentum takes place among the bodies is called a collision. Okay, so just you can now the sentence formation you can take anyway. Okay, as right. So this briefly, collision is an interaction in which momentum exchange of momentum takes place. So these collisions, we have discussed that these collisions have classified into different types. These collisions are classified into different types. One of the classification which we have discussed, two kinds of classifications we have discussed. Out of this, one of the classification which is carried out by taking into consideration the direction of motion. So we can say, based on direction of motion, collisions can be classified into two types. You can say based on based on direction of motion of which ones of the colliding bodies of bodies based on direction of motion of bodies. The collisions are classified into two types. The collisions are classified into two types. Come on, namely, we can write viz, viz. Viz means namely you can say one dimensional collision, and we have discussed about oblique collision. One dimensional, we can write one dimensional collision, or one dimensional or 1D collision also you can call it as 1D collision, one dimensional or 1D collision. And this, another one which is oblique collision, oblique 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 collision. Okay, so here this one dimensional collision can also be called as head-on collision. You can write this additional point here, you can also call this as head-on collision. Head-on collision, one dimensional collision can also be called as head-on collision. And oblique collision, already we have discussed that this can be either a two-dimensional or three-dimensional collision. Two-dimensional and three-dimensional collisions together can be called as an oblique collision. And we have discussed briefly what is one-dimensional collision and what is an oblique, two-dimensional or three-dimensional collision means also, right? One dimensional collision means, what did we discuss? You can go through your notes already, if you have that notes which you have copied earlier. What is one dimensional collision is when the bodies moves along the same line before and after collision. You can also use some different words instead of using the words when the bodies move along the same line before and after collisions. You can also say if the velocities of colliding body are in the same direction or in the same line before and after collision, means the body should be moving along the same line before and after collisions. Such kind of collisions are called one dimensional collisions or head-on collisions. So those who have not copied, you can copy this. One dimensional or head-on collision. One dimensional collision. One dimensional or head-on collision. One dimensional or head-on collision. What is this one dimensional or head-on collision? So if the bodies move in this along the same line before and after collision, if the bodies move along the same line before and after collision is called one dimensional or head-on collision. So we can also define this in terms of velocities as if the velocities of the colliding bodies, are in the same straight line, are along the same straight line before and after collision. So you can I will show you with the help of a small simple diagram. If there are two bodies, this is m1 and another body m2. If it is moving with some velocity u1, this is moving with some velocity u2 before collision. Now, if you draw a line joining the centers of these two bodies, you can say they are moving along this line. before collision. So the velocities are along this line. Now after collision, the velocities have changed. So provided here if u1 is greater than u2, this may come and hit this. So after collision, the velocities changes. u1 velocity of the first body changes to v1, and velocity of second body, let us say, changes to v2. So they undergo some collision for a short moment. After collision, this is m1, this is m2. Then after collision, if m1 is moving with velocity v1 and m2 is moving with a different velocity v2, this is after collision. After collision, such that they are moving along the same line as that of the before collision. Or you can say, if the velocities of the colliding bodies are confined to same straight line before collision and after collision, such kind of collision is called one-dimensional collision. Such kind of collision is called one-dimensional collision or head-on collision. One-dimensional collision or head-on collision. An example. So this is one of the examples you can say, or you can also recollect back one of the examples from your chemistry. In chemistry, you might have studied one chapter called atomic structure. The same chapter we are going to study in the 12th standard. In that, from that concept, if you recollect back one simple conceptual example like alpha scattering experiment, you can understand one thing. That is, if uh, there is a nucleus having charge Ze, and if an alpha particle is moving along the line passing through center of this nucleus, alpha particle, after reaching a particular point, it stops and retraces back along the same line. So here we have to consider this as a collision. But one more point we have discussed during this discussion was, for a collision to happen, two bodies need not to be in physical contact always. They may or may not be in physical contact during a collision. So that point also you guys have to remember. This example says that when a collision is happening, two bodies no need to be in physical contact. So here this comes and stops here, and it retraces back. That means you can have to say they have undergone a collision. In this collision, alpha particle is moving along this line before collision. After collision, it is moving along the same line but in opposite direction. So this can be considered as a head-on collision. This can be considered as a head-on collision. Got it? Yes, this is another one of the very good example of what you call one-dimensional collision or head-on collision. So here you better write down a note that is, uh, during collision during collision during during collision, you can say the bodies may or may not be in physical contact. May or may not be in physical contact. May or may not be in physical contact. Without physical contact, how the bodies will collide, sir? You may ask. That's why I have given you this example. So you can also consider one more example, something like if you have any two charged bodies having charges q1 and q2. Q1 and Q2, let's say they're having like charges, plus plus or minus minus. If they're coming together and after approaching a particular separation, they will repel each other. Like bodies will repel. And also two magnets. If you bring two magnets, magnets also will repel. If like poles of magnets we bring closer, they will repel each other. This kind of interaction is also called as a collision. A collision is nothing but an interaction in which exchange of momentum takes place. So it is a collision. So in a collision, during a collision, the bodies may or may not be in physical contact. So actually, in few of the competitive exams, some conceptual questions have asked based on this point already in the previous years. So try to keep this point in mind. Note down this point and remember, during a collision, bodies may or may not be in physical contact. That means for a collision to happen, bodies no need to be in physical contact always. So if you take your hand and if you hit on the wall, you can say it is a collision. There, the wall and your hand will be in physical contact. But if for for collision to take place, two bodies need not be in physical contact always. Example is this. What is that? Alpha scattering experiment. This is, you can also here, you can write here, alpha scattering experiment. Alpha scattering experiment tells about this. And interaction between two like charges. Another example, interaction between two like charges. And another example, interaction between similar poles of two magnets. Two magnets also can consider here, right? Next, the next one is let us see. We have discussed briefly about one-dimensional collision. One-dimensional collision or head-on collision. The next one is oblique collision. So two-dimensional and three-dimensional collisions together will be called as oblique collision. So what is that? Let us see briefly oblique collision. So you have to say just you can recollect back that when two bodies are not confined to same straight line before and after collision, such kind of collision will be called as an oblique collision. In one-dimensional collision, two bodies should move along same straight line before collision and after collision. So it is one-dimensional. If two bodies are moving in along same straight line, after collision, this body move in this direction, this body may move in this direction. So such kind of collision will be treated as, will be called as a an oblique collision, will be called as an oblique collision, right? So you should understand this, what is the meaning of this. So clearly I'll give you the pictorial representation of that also. So write down next, oblique collision. oblique Oblique collision. So what is oblique collision? The collision in which the collision, write down, then you can understand with the help of a diagram, simple diagram. The collision in which the, you can say, the colliding bodies, in which the bodies colliding bodies are are not confined to move, are not confined to move along the same straight line, are not confined to move along the same straight line before and after collision, are not confined to move along the are not confined, you can underline this word, not confined, are not confined to move along the same straight line before and after collision, before and after collision. Okay, such kind of collision is called oblique collision. So it can be a two-dimensional collision or three-dimensional collision. Okay, that also just you can mention that. Okay, now so you can note down this, so if two bodies m1 and m2 are moving with velocities u1 and u2, so they are moving along this same line. So they undergo some interaction for a short interval of time, m1 and m2, so that after collision if this is initially the line along which they are moving, you can we need to discuss a few more terms, two terms here: line of motion and line of impact. After this, just we'll see what is line of motion and what is line of impact. Okay, so after collision, so if m1 is moving in this direction, let us say, and m2 is moving somewhere in this direction, then you can say the line, they're not confined to move along the same straight line before and after collision. Such kind of case or such kind of collision can be termed as or called as an oblique collision. Got it? This is called as an oblique collision, right? So this is briefly about what is a one-dimensional collision, or head-on collision, an oblique collision, or two-dimensional, three-dimensional collisions. So if you just the bodies are moving in a plane, they may move in a space also, three-dimensional space also, right? So next, another kind of classification of collisions is based on conservation of energy, right? Let us see those points. What is that? What is that classification of collision based on conservation of energy? Based on conservation of energy, collisions are classified into two more types. Based on, so you can say based on conservation of energy. Based on conservation of energy, comma, collisions are classified into two types. Collisions are classified into two types, comma, viz means namely, the number one is elastic collision and the another one is inelastic collision. Elastic collision and the another one is inelastic collision. Inelastic collision, right? So so some books you may come across elastic collision, perfectly elastic collision, inelastic collision, perfectly inelastic collision, and semi-elastic or semi-inelastic collisions, like this. But so these are general classification of collisions. Those will come the other kinds of, say, what is elastic collision, what is inelastic collision. If you understand the other kinds of collisions, you can understand, and you can understand how to deal with them, right? So let us try to recollect back what is elastic collision means. So elastic collision is what we have studied already. What is elastic collision, right? The elastic collision is nothing but the collision in which both momentum and energy, kinetic energy, will conserve. A collision in which both momentum and kinetic energy are conserved. Such kind of collision is called elastic collision. Whereas inelastic collision, the collision in which only momentum is conserved but not kinetic energy. Is called inelastic collision. Inelastic collision. So write down. So what is elastic collision? So the collision in which, what is elastic collision? The collision in which both momentum, small p you can write, and kinetic energy momentum and kinetic energy are are conserved. The collision in which both momentum and kinetic energy are conserved is called elastic collision. Whereas what is inelastic collision? Yes, the collision in which only momentum is conserved, only p, the momentum p is conserved, but 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 not kinetic energy, but not kinetic energy, or you can say only momentum is conserved but kinetic energy is not conserved, is called inelastic collision. Right? So this elastic collision may be one dimensional or two dimensional or three dimensional. Similarly, inelastic collision may be one dimensional or two dimensional or three dimensional. So this is how we can also interrelate elastic collisions and one-dimensional elastic collision and two-dimensional collisions also, right? So elastic collision may be 1D or oblique collision, head-on collision or oblique collision. Inelastic collision also may be 1D collision or oblique collision also, right? So let us see now few examples for these elastic collisions. So examples for elastic collisions. Examples for elastic collisions. For elastic collisions, already I have discussed that what is this, the one of the previous one under the head-on collision is alpha scattering experiment. So alpha scattering, okay, alpha scattering experiment, or you can say that scattering of alpha particle can be treated as one of the elastic collision, or collision of alpha particle with the nucleus. Alpha particle is scattering from the nucleus means because of their like charges. Alpha particle is positively charged, nucleus also. Here alpha particle will be positively charged, the nucleus also positive charged. After reaching here, they will repel each other. The repulsion will be so much strong enough so that they will stop here, and they will the alpha particle will move away from it along the same straight line. So it is called as elastic collision, but it is one-dimensional elastic collision. One-dimensional elastic collision. So you can call it as head-on collision. So one of the examples for elastic collision is collision of alpha particle with the nucleus. Collision of alpha particle with nucleus is an elastic collision. And another one is collision between any kind of, we can say, between atomic particles, between any atomic particles, any charges or atoms, any atomic particles. Collision between any as there is a question from Sanjay, sir, for this week do you have only collisions? Yes, no, Sanjay, we will be having only collisions. There are different special cases are there as part of the collisions. So we will do the numericals based on those special cases. Okay, yes, we have collisions for this week. We have completely collisions. It is not only collisions. Collisions is not that simple concept. It is a very big and very important concept. It is a very big concept actually. Okay, it needs more time. It requires more time. Okay, yeah. Collision between and the another example for elastic collision is, I can say, between any subatomic particles, between atomic particles or subatomic particles. Subatomic particles can also be considered as an elastic collision. Okay, so any collision which is happening is so that there is no what do you call, loss of energy is taking place. Say for example, if you take two spherical balls, and if you keep one ball at rest, and if you hit the another ball, and if it goes and hit it, both may move, or one may stop and another may move. Okay, but if you may heard some sound, that means what, that means you are giving, if you give some energy to a spherical ball, that energy is going to, a part of it is going to give it to another ball. So in that interaction, a part of energy is converting into sound energy also. So that means energy will not be conserved. Such kind of collisions can be called as what are called inelastic collisions. So energy will not be conserved. So if energy conserves completely, then it will be called as elastic collision. Usually in day-to-day life, in practical life, almost all the collisions will be inelastic only. Elastic collisions will be observed only under ideal conditions. So elastic collision is only can be observed only under ideal conditions. So in everyday day-to-day life, energy may convert from one form to another form during a collision. Say for example, if you consider in a road, some accident has taken place, a vehicle is moving, a vehicle is coming and colliding with that. So there the energy may not conserve. So that you may hear big sound, big noise, and hence some heat energy also will be produced. So whatever the energy they were having before collision, the kinetic energies, they will be transferred in another forms. So energy may not completely conserve such kind of collisions. So which whatever you come across in our day-to-day life, in practical life, will be called as inelastic collisions. Will be called as inelastic collisions. Okay. This is briefly about the what you call elastic and inelastic elastic collisions and examples. Inelastic collisions already you have copied the collision in which only momentum is conserved but not kinetic energy, right? So here you need to have an idea about just that you can take this an example for inelastic collision is the collision between two vehicles. You can take this as the collision between any bodies in the day-to-day life or inelastic collision, that way also can take. So specifically if you want, you can take this as an example. What is that? The collision between two vehicles. Collision between two vehicles. Two vehicles is can be considered as an inelastic collision, can be considered as an inelastic collision, right? Whereas here you need to have an idea about one more collision called perfectly inelastic collision. If you just here itself you can consider the types of collisions based on conservation of energy: elastic collision, inelastic collision. Just some books will give you here itself as a third type, that is perfectly inelastic collision. So let us see briefly what is perfectly inelastic collision. Perfectly inelastic collision. Next one is perfectly inelastic collision. Perfectly inelastic collision. What is perfectly inelastic collision? Inelastic collision means momentum only conserves but not kinetic energy. Then what is this perfectly inelastic collision? So simply we say that inelastic means obviously energy may not be conserved. But what is this in perfectly means is, if two bodies are moving, m1 and m2 with some velocities, after collision energy is not conserved. But if they are moving with the common velocity, the two bodies stick together and moving with common velocity, such kind of collision will be called as perfectly inelastic collision. Let us say there are two bodies, m1 and m1 and m2 are moving with velocities u1 and u2 before collision. This is bc means before collision, and they may undergo some collision for a short interval of time. After collision, let us say they are stick together, and m1 and m2, they stick together, and as a whole these two together as they are moving with a common velocity v. This is after collision. AC means after collision, right? BC means before collision they are moving with different velocities, but after collision, if the bodies stick together and moving with common velocities, a single velocity or a common velocity, such kind of collision will be called as perfectly inelastic collision. Write down this. Those who have not copied, is called as a perfectly inelastic collision, right? So let us see now few terminology. So just I hope you have copied this, everyone. So you can write down those who have not copied. What is perfectly inelastic collision? If two bodies, if two bodies, if two bodies move with a common velocity, after collision. If two bodies move with a common velocity after collision, such kind of collision is called perfectly inelastic collision. So you can write, if you want some example, you can write down something like this. If you fire a bullet fired into a wooden block, and it remains embedded in the block, it is not coming out of the block, it is just it remains embedded in the block. Such kind of collision will be called as perfectly inelastic collision. The block may be at rest, bullet and the block may be at rest, or the bullet will be moving along with the block. Okay, either way, but they should stick together. They should stick together after collision. Such kind of collision will be called as perfectly inelastic collision, right? Now let us try to discuss few points. This you can write down this example, guys. You can write down this example for perfectly inelastic collision. What is that? A bullet fired into a wooden block. A bullet fired fired into a wooden block. A bullet fired into a wooden block, and both will stick together, I can say, and the bullet embedded in it, and the bullet remains embedded in it, remains embedded in it. Okay, is an example for perfectly inelastic collision. Now let us see few terminology test here. So what is the line of motion and line of impact? Line of motion and line of impact, just only the main important term what you need to have clear difference is what is line of impact. To understand this, you should know what is line of motion, then only you can distinguish this. So first of all, what is line of motion is the line passing through the line passing through the centers of the bodies along which they are moving. You can say it is sometimes if you draw a line, if you draw a line through two bodies, if you draw a line through centers of two bodies, sometimes the bodies may not be in all these cases the bodies may be moving along the line passing through the centers of the bodies, but not in all, not in always. Some cases one body may be moving in this direction, but another body may be moving in some other different direction, so they collide, or only they touch and they collide. So in such kind of cases the line of motion will be different. Not line of motion is common for the two bodies always. Okay, so just to understand that, let me draw one simple example here. Two examples I will two simple diagrams I will draw here, then you can understand what is the meaning of line of impact. Let us see first what is the meaning of line of impact. To understand this, you should know what is the meaning of line of motion. So the first one is, let us see, if two bodies during they're moving, m1 and m2 are moving with velocities u1 and u2. during the collision they come to contact like this. This is m1, this is m2. What you have to understand here is, this may be the center of this may be the center of the second one, provided here if you observe the line passing through the common normal to the surfaces in contact. This is the surface of the first body at this is point of contact. At the point of contact, the surface of the first body is this, and at the point of contact, surface of the second body is this. If you draw a normal to the surface of the first body and normal to the surface of the second body, this will be normal. Normal means the line which makes 90 degrees with the surface, which is normal, right? So both are having a common normal. The normal to the surface is this. For the normal to this second surface of the second body is also for first body, second body. For both bodies, normal to the surfaces is same here, and you have to just understand that this line. So after collision, what happens is, if the body is m1 and m2 may be moving with different velocities, but they along the same direction, whatever it is, v1 v2, but along the same direction, then you can say the line of impact and line of motion both are same. You can say both are same. So this is the meaning of it. So line of impact and line of motion. So line of impact is a common normal. This is the common normal to the surfaces in contact. This is line of impact. Here along the same line only they are moving. So you can say in this case line of impact, line of impact and line of motion are same. So to understand that, write down separately the definition of line of impact. Write down everyone, definition of line of impact. What is line of impact? The line passing through. So guys, just we are discussing only the conceptual points only in today's session. Okay, so there are some derivations are there already in the last session also. I have just told you that. So some of you guys have missed the session. So in this session also, just I am dealing the conceptual points. In the next session, we will try to discuss some what you call mathematical relations, which involves conservation of momentum and conservation of energy, and then we'll try to work out some numericals, right? Okay, let's go ahead now. So what is the line of impact? The line yeah, write down the line passing through. Is there any questions from the chart? Let me see the chart once. No, I think only Sanjay has asked that. Yes, I am clarified this. I think Sanjay, so everyone is clear about this portion, right? Tanga Prabha, Preeti, Sanjay, Aglesh, Sarvan, Vijay. Yes, good Nana. Yes, welcome everyone and good morning once again. I hope this is your question. The answer for your question is clear, Sanjay, right? Go through this now. Go through this, everyone. Right? The line, write down what is the meaning of line of impact. The line passing through, the line passing the common normal, passing through the line passing through the common normal to the surfaces in contact, to the surfaces in contact, during the collision, underline this, during the collision, the line passing through the common normal during the collision. This is very important. The line passing through common normal during the collision is called line of impact. Is called line of impact. Is called line of impact. Is called line of impact, right? So to understand this, we can take this as an example. So just separately also you can write down this. So how can you distinguish line of impact and line of motion? With the help of another diagram, if you see, it will get a little more clarity. Let me give you another pictorial representation here. Another pictorial representation. Another example I can say otherwise. So let us see here. There is one body M1 and it is moving, let us say somehow in this direction, right? And there is another body M2. There is another body M2. This is moving in this direction. So here, after coming closer, they may, M1 may be here, and as because it is moving in this direction, and M2 may come into contact with this somewhere here. This time I may be drawing a little smaller and bigger here. Don't confuse why this is like this. Right? So this is how it is moving, and this is moving in this direction. So now the line of motion of this is first body, this is second body. For first body, this is called line of motion. So this is center of first one, this is center of this one. So if you draw a line passing through the centers, line passing through centers, and here during the contact collision, the normal to the surface and normal to the surface will process like this. This is the normal to the what you call surfaces in contact during collision. Common normal to surfaces, common normal to the surface, normal to the surface. So common normal to the surfaces in contact during collision. So this line will be called as line of impact. Line of impact. Whereas the direction in which the particle 1 is moving is called as a line of motion of particle 1, and this line will be called as line of motion of particle 2. So line of motion of particle 1 and 2 are different, but line of impact is different. But if you compare with the previous one here, so before collision, they are moving in this direction. This is the line of motion of the first one is this. Line of motion of second one is this. Both are having same line. And during the impact, the common normal is to the surfaces in contact is this. A line of motions of these two bodies also along the same line. So here, so line of impact and line of motion are same. That is the difference you have to understand. Okay, what now I hope it is very clear what is line of motion, line of impact means. Line of impact is again what is line of impact? The line passing through common normal to the surfaces in contact during the collision is called line of impact. Common normal to the surfaces in contact during the collision is called line of impact. So line of impact and line of motion need not to be same always. So these examples will tell us clearly about this. So note down this, everyone. Note down. So this kind of collision. So here in the this one you can say before collision and after collision they are moving along same direction. So we can call this as one-dimensional collision. One-dimensional collision or head-on collision also you can say. But here they are moving in, of course, in different directions, not along same line. After collision also they may move in different directions. So this kind of collision can be called as oblique collision. This can be considered as an example for oblique collision. Oblique collision. Right? Have a note of this point also. So likewise, this we can have line of impact and line of motion differently. Right? The another example, just I will give you one more example to understand this. One more example. If you have a wedge shape, if you have a inclined surface or wedge shape, inclined surface, the angle of inclination is theta, something like this, and it is there is a wedge, it is lying on surface, let us say, and if you have a block of mass m, this is say having some mass capital M, or you can say this is m1, this is m2, either way you can consider. It is at rest, this block is at rest, and when this is falling vertically down, and when it falls on this during the interaction, so this is the surface of M and this is surface of the block. So the normal to the surface at this point, normal to the surface of the wedge will be this. So common normal to these two surfaces is this. So here this is line of motion. This is called line of motion. Note on this also, guys. Whereas this will be called as line of impact. Line of impact. So line of motion and line of impact are different now. Here also different, but only in the first case they are same. Okay. So write down this. So line of motion and line of impact are different in this case. Yes, guys. So I hope these points are clear. In the next session, we'll write down a subheading. That we'll continue that. And the next point should be we'll discuss about an elastic collision in one dimension or one-dimensional elastic collision. Write down subheading. One-dimensional elastic collision. One-dimensional elastic collision. Under this, we'll discuss about how to apply law of conservation of momentum and law of conservation of energy, and by knowing the masses of the any two bodies and their initial velocities, how can you find the final velocities? How can you find the final velocities after collision? These points we will discuss in the next session. Okay, these points we'll discuss in the next session. Write down the subheading, and from here onwards we'll continue, and we'll discuss some special cases under this. Then we'll try to work out few previous years questions also based on this concept. This is one of the very important concepts. Try to follow carefully now. Okay, take care everyone. I'm winding the session now. Take care. Bye bye.